We're looking at a velocity time graph, otherwise known as a speed time graph. And as you can see, the two most important facts about this graph are the gradient is the acceleration and the area under the line is the displacement. And so we look at a question now. The motion of a particle is described by this graph. And we have a number of changes. We have an acceleration, a constant acceleration. There's a few things going on here. We also have two unknowns, t and v. So we have a distance from t to 36, which is 150 meters, and the whole motion is 309 meters. We're talking about distance. That makes me think about area under the graph. And I know there's unknown values, so there's going to be a little bit of something going on with equations as well, possibly simultaneous equations. Okay, our shapes 1 to 5. Let's do out our area for each of these. First one is a trapezium. That should be straightforward. Next one's rectangle, then a trapezium, then a rectangle, then your triangle. I'll just write these out. Just while I'm doing this, there are other motion graphs, such as displacement time graph. Not on Cambridge, but on other courses you might have an acceleration time graph, but you will also have a small part dealing with discontinuities, which is a little bit similar. So looking at the key features of those as well would be important. Okay, our next one is a trapezium. Here we come across our first unknown value. So we're looking at V, and is there a T involved? Not just yet. So just figure out, you know your trapezium rule. Your trapezium formula, I should say. So I'm left with an equation. Our fourth equation here also has the unknown of t. So let's set this one out just like the previous. E minus 13 is the base there, or the width if you want, times v, which is our height or length in that context. And last one, a triangle. Half times base times height. Now while I'm doing this, we actually have an answer down below. We have some more information that we've been given. It tells us that the distance from T to the end of the line, 36, is actually equal to 150. Have a think about that for a second. And the whole motion was 309. So putting this all together seems to be the right pathway. 39 plus 27 plus 2v plus 9. You could multiply them out if you want in advance. 2v plus 18. Expand your brackets. You can do it whenever. I've actually used a capitalized T here. I think I've used a lowercase t earlier. Don't worry about that. My bad. So we've put them all together, and we're going to make them equal to 309 meters. What else can I do? I've already stated that one of our equations, or answers from above, is equal to 150. And if you actually check it just there yourself, you'll see that 1/2 v, bracket 36 minus t, close bracket, is equal to 150. Do we have a value for v or t? Yes. Perhaps not. But remember, you can find, just doing your algebra out, you can find a value for t or v, and maybe you could substitute it in. So we've just solved our equation there, 39 plus 27 plus our three equations equal 309, and we've simplified it down. So 2v plus v times t times v minus 13v is vt minus 11v, and I've kept that in brackets there. And from there we can find v or t, but v is equal to 75 over t minus 11 if we divide t minus 11 on both sides. So now that we have one of our unknown values, it doesn't look very pretty, but we can actually substitute it in now. And we should substitute it into something that we can solve. So a half v, bracket 36 minus t, close bracket, that we were given, that equals 150 meters. We'll put in our value for v there, as you see. And again, it looks a little bit difficult, but you need to practice your algebra. It's mostly algebra from now on. And there, you should get t is equal to a nice whole number of 16 seconds. Plug your t back in. Plug your 16 seconds back into one of your formula. And you should get your velocity. And velocity is close enough, 15 meters per second. And that's our answer. We found the two unknowns, t and v. It took a while. It's an expansive question. That's the kind of question you might get, and keep in mind you might also have to draw or sketch a velocity or displacement time graph. And so have a look over those details and keep practicing. And you have no choice but to improve. Maths is so cumulative, you just keep going through it. So just building on previous learning and building your skills up, and you will be successful.